All right. Hi, I'm Mark. I'm going to tell you today about basically what I do at work. Right? I work at Facebook, and what I do there is I make it easier for people to write code, and I let them focus on particularly the problems that they care about. Right? When you write code, what you want to do is just that one little part of your job that you love. Right? Like, ask yourself the question: what percentage of your job is stuff that you really, really enjoy? And everything else is kind of getting in the way of that. And so what we're going to talk about today is in service of that goal of doing only the things that you care about and having confidence when you do them, being able to do them in a way that's safe. Now, it says C++ on the slide, it's in the title. There isn't actually a lot of code in this talk. Never mind C++, right? Just not much code at all. This talk is about the tooling that lets you write that C++, the tooling that lets you focus on that part of your job, that aspect of your job that you love. So I just want to prepare you for that this is a talk about tools. This is about letting you do what you do better. So opening with a list of questions, right? These are kind of vague, hand-wavy questions, things that I don't know if any of you have ever actually asked yourselves, either out loud or even in your head, just explicitly. How do I prevent my code from being broken? Right? That's what this talk is really going to come down to, is how do I make sure that the code continues to work? Okay, well, I'm going to make a statement. And that is, it's not enough to know that your code builds and passes the tests to know whether or not it is broken. And that goes to the question of, what does broken actually mean? So let me back up a step and tell you what I mean by that. If the builds and tests pass, you're on a good start. What about undefined behavior, non-determinism? What if your tests pass this time, but they won't the next time? At least not all of them. So that's an example of how just doing that doesn't mean that your code is good. And I'd like to actually ask you, right, what does broken mean to you? What could we layer on top of this primitive definition of broken in our code bases? What might we want? Crashes. Okay, does it crash? Right? Great answer. What else? Undefined behavior, more non-determinism. What else? Say again. So a deadlock or an infinite loop. Yeah, absolutely. Let me throw out a different axis for you. What if the code does exactly what we wanted it to do, it's just too slow? Is that broken? Right? I can't tell you. That depends on your product. But that might be something we care about. Did we pick the right algorithm? Did we implement it in a way that's sane? Other ideas? Badly written. Sure, we could include that actually in our definition of broken. That's kind of more broken for the engineers than it is for the consumers, but why not? I've got another one for you. I think this is a room mostly full of people who do infrastructure work, but what if you were working on a UI? Is it sane? Is it something that the customer can actually understand? Is it what they wanted? Right? The code might be correct, it might be fast, it might do what you thought they wanted, but not what they actually wanted. All stuff that I like to think about. Right? What does it mean to actually ship something that works? And we have tools that can figure out, did it break? Easiest example, if I've got a compiler, GCC or Clang, look at the return code. Is it broken or not? Very good binary definition. And I'll try and talk to you more today about why you don't just want to know, is something broken? You really have to know why. And not only do you have to know it, you have to make that information extremely available. And I'll show you that with pictures. It'll all make sense. There's some stories. It'll be a good time. The last question we'll come back to later. So if these questions seem easy, I just want to take a moment to step back and remind you that we're talking about these at scale. We're talking about thousands of developers, hundreds of thousands of files. We're talking about a code base where we continuously are shipping projects. Every day, all kinds of stuff gets deployed. And it could affect literally billions of people. So the stakes are high. And the other thing that I kind of need to mention for us is we don't have 30 Git repos or something like that, one for each project or something like that, not that there's 30, but we have one monolithic repository. And what that means is all the code's in the same spot. It can all depend on everything else, and often does. And we build things from trunk. So it's not like there's a stable version of Thrift, our RPC protocol, that everyone just says, use the stable version. You are building off of trunk. You are building off of master. That's what we're talking about here. How in that world do you prevent stuff from being broken? That's what we're going to talk about today. And I'm gonna kind of craft a story for you from start to finish of you're making a change to the code base. What does that process look like? What are the steps involved where we try and help you to answer those questions? And I'm going to begin with this example here. We're going to talk about error messages, and we're going to go through the code review process. We're going to kind of wrap up with what if we missed something? What if something gets through? What then? Because that actually is a much more difficult problem. So at the beginning, here's a G-test test, right? I'm a good software developer. I wrote a test. Awesome. It happens to do something quite silly, which is just, is this thing 5, yes or no? And if I run this with stock G-test configuration, I'm going to see the following error message. It tells me the file name, the line number, tells me roughly what went wrong. This is pretty good. Well, maybe my program is more complicated than this. For starters, like, which of these lines in the test case actually invoked that function? I don't know. What if instead of being, one layer deep, it's actually a dcheck macro, and that's in some proprietary hash table implementation that you have, right? That's probably used in all of your tests. What then? Where did it come from? What I'm telling you is I want a stack trace. That's what I want. I want error messages that are awesome by default. I don't ever want to have the problem of, oh, this crashed in production, it told me the line number, I didn't know how it got there, let me rerun that in GDB and just hope that there's no non-determinism involved and we see that bug again. That's an awful experience. So what I want is for a full stack trace to happen every single time, whether it's on your dev box, whether it's running in production, whether it is on our test machines, no matter what, every time print the error, the full thing, as much information as you can, at least, reasonably cheaply. And it turns out you can do this. This is easy to do. You can take it today, go home to your code base, and set it up. It's pretty simple. And here's how we did it. So I need to give you a little bit of background first, and that is the way that we wrote our tests is we did not write our own main functions, at least most of the time. There's a main function that comes with G-test. It comes with the Google testing framework. You link that in. All it does are the top and bottom lines there. It initializes the Google test. It runs the test. That's all it does. So because we linked in our main function, we didn't write one ourselves, we have an opportunity, which is to switch it to something new. Switch it to this, where we layer in a few extra things that benefit all of our tests at the company. We added 2 lines. And those 2 lines come from our flagship open source C++ library, Folly. So you can open that up, you can find it, you can actually find this main function. It's in a test main.cpp file, I believe. And this is just going to make all of those error messages better, for free. Right? Who doesn't like that? And it's not just those, by the way. It affects a few other classes of errors, not everything. But better debugging makes such a huge difference. There were all kinds of mystery errors that we were seeing in our continuous integration system. No one knew what was going on. And the minute we dropped this in, we did it overnight, suddenly we understood, a whole bunch of stuff that we used to not understand before. Now there's some magic on the slide that I need to talk about. That's that top line. Right? That's probably the most confusing part here. Attribute weak, what's going on there? This is to make this easier to use. So attribute weak says, link this into any binary that you want, take this compilation and link it in to anything. If the binary you're linking it into already has a main function, just use that, otherwise use this one. So you don't need to know ahead of time, is it safe? You can just turn this on for your code base, put it into your build tool, link it into everything, and retroactively start ripping out the main functions that you don't actually need in the first place. So, all right, step 1 for us, better error messages. When you're developing locally on your box, tell you the information you need. Step 2 is code review. And this is where really all of our tooling power comes to bear. And is going to help us answer this question. And for us, it starts with automation. So we start with linting. Now for us, I've got a picture here of Fabricator. That's our code review tool. It's kind of like GitHub, but a lot better. And I've got an inline comment here, so it's contextual information, and it's throwing in a compiler warning. It's saying, hey, you're not using that variable. You probably meant to. What's going on? And this is information that you can see, that your reviewer can see, that anyone who passes by can just see. It's right there, right at the spot where it matters. So a theme that we're going to come back to is you can have all the answers. You can know that something is broken. How you communicate that is actually crucial. Having it be inline makes it really hard to avoid. It makes it so that people are aware that it's there and that they know how important it is. So this is just important stuff. Now, I mentioned linters. Warnings are kind of, let's say, the lowest form of that, the least complicated, the one that everyone's familiar with. But linting is a huge opportunity. And what I mean by that, I mentioned in the talk I gave yesterday, there was a bug that I faced a few years ago, which was there was a lock guard that did not have a name. And so it came into scope and out of scope immediately. And that meant I had no critical section at all. Right? Nasty, nasty bug. Took a whole lot more effort than I'd like to admit to figure that out. And that's accumulated wisdom. Right? Anytime one of your engineers at your company has a bug like that, where they spend a full day trying to figure out this nasty thing that, frankly, you could have found with a regex, that's an opportunity. Write a tool that finds that, plug it in your code review system. We have thousands of developers. If we don't take these lessons and put them in our tool, we are losing who knows how many hours. All right, enough of that. Builds and tests. This is a deceptively simple image of what it looks like at the top of our code review page. So, got a UI, it tells us, hey, you've got some failures, you've got some stuff that succeeded. This is much more nuanced than it appears. It took us a while to get a UI that's even this good, and we're actually working on it a lot because it needs a lot of work. But I need to tell you a story. So I'm going to tell you a story about back when I was an intern many, many years ago and working on a C++ project. And what happened was I would put up a change for code review. I'd work really hard, get something ready, shove it in, and I would expect to see two colors. Right? Today there's many, but back then it was just two. Is it green or red, good or bad? And I expected to see about 10% of things come back as red. Right? Whatever the number of jobs was, 10% of them was about the right number of things that came back as red. Reliably, every time. Doesn't matter what you changed, could have been a comment. Right? This was years ago. That's kind of awful. So I want to ask you, I assume the answer is clear, but why do you think that is? Why, if I change comments, am I going to see stuff that shows up as red? Stuff that fails? Flaky tests, thank you. Thank you. So tests are written by all of you, right? Some of you, I've certainly been guilty of writing tests that aren't the best. Right? People write all kinds of tests. Some of them are awesome. Some of them talk to the database. Some of them write to disk with a very specific file name, not a one that calls the correct temp file stuff. All kinds of stuff goes into your tests. And they're not really that trustworthy. And if you imagine that every single test has a failure rate of 1 in 1,000, let's assume that they're that good. Take that, 1 in 1,000, multiply that by the number of tests in the code base. And let me remind you, we have hundreds of thousands of files. So how many tests do you think that is? That is the expected value for the amount of flakiness that's going to show up. And that's why 10% of things would show up as red. And that was an awful experience. That meant if I saw 10% of failures, I just assumed that was noise and I shipped my code. So how do I prevent people from breaking stuff? They have to trust you. Right? Bottom line, I can tell you all of the real bugs. I can tell you every single one of them. But if I also throw at you, 10 times as many things that are noise, we've got a huge problem. We're going to come back to that idea. So suppose my tests are just as flaky. I've done nothing to solve that problem. Let's assume we're in that world. We have done a lot. I'll talk about that in a bit. The easiest thing you can do to combat this problem, the easiest thing we ever did, was to add some colors. We said build failures are this color, test failures are that color. That's all we did. And the reason why this works is test failures are crap, right? Like they can be noisy if you assume we're still in that world. But build failures, I know compiler writers. I've talked with them. I've talked with people who work on Clang and GCC. And what they tell me is they have spent an enormous amount of effort to make sure that everything the compiler does is deterministic. Their data structures, they go out of their way to make sure that whatever happens when you run a particular compilation with a particular input, it is the same thing every single time. So even if the compiler does have a bug and it crashes, you'll see the same crash every single time. And so build failures are extremely reliable. And what's more, they're the most devastating things if they slip by. Right? They prevent you from actually doing your job. They prevent you from catching the test failures. So build failures are awesome. And so just labeling them differently means I can trust the build failures and not trust the test failures. So labeling matters a ton. Right? Maybe you didn't expect that to be the lesson at a C++ talk, but there it is. Colors matter. Right? Put them on your code review tool. Now, there's some other stuff here. Important things, just I'll briefly say, you also want to have a different label for this isn't your fault. Right? The build tool itself crashed, for example. If that is what happened, you don't want to be telling people that they broke it. It's not their fault, it's an infrastructure issue, it's a tooling issue. That'll save you a lot of trust as well. And that gets me to this next point, which is green doesn't mean everything worked. It's not what it means for us. Right? When I see a success here, that doesn't mean every test passed in Folly. That means I didn't make the situation any worse. Right? There might be some stuff that's broken, but apply my change on top, I didn't break anything new. This is the question that developers actually want. They don't want to know, is it broken? They want to know, did I break it? We're selfish. Face it. Right? That's what we want. That's the question that we're trying to ask when we put our stuff up for code review. And the way we achieve that is, if we do see a failure, well, what we're going to do is we're going to check out to the revision that your stuff is based on. So we're going to unapply your patch and run the test there. And if it fails on both of them, we know it's not your fault. Great way to build trust as well, because now you're only telling them about things that they care about, things that they're motivated to go and actually fix. This also gets rid of a whole bunch of noise as well. So you can imagine a machine, for whatever reason, can't talk to some other machine. Right? If that's the problem that you have, well, then the test is going to fail on both revisions. Right? With or without your changes applied, it still can't talk to that machine, so we're going to catch flakiness of that form, which is nice. Okay, so green means nothing new. Great. We did actually do some stuff to make it so that there's less noise in the system. And one of the things that we did is we added these things called wardens. Now what I've got for you on the bottom here is a graph of a test's pass-fail history. So this really is the just, binary, was it good or was it bad, over time. And we can see it kind of started off pretty good. It started having some flaky issues over there. And whenever we see an isolated failure, or an isolated passing thing, right? If it's failing consistently and then it passes once, that's also flaky. We label it. We say, hey, run this through the wardens. Run it for stress testing. And that's what a warden is. What it does, it says, take all of the tests with this label and run them in parallel with themselves, let's say 20 times. So you do that. And if the outcomes are not all the same, if it doesn't all pass or all fail, then we know it's flaky. And it turns out this is a really good way to detect certain kinds of flakiness. It catches issues like, is the database under load? Because if your test puts it under load and that's what's causing the flakiness, well, running it 20 times in parallel, that's definitely going to put it under load. You're going to notice. So it catches stuff. The other nice thing about this is that it turns out in practice, it's really reproducible. If I see that a stress run says that something is flaky, and I rerun another stress run, it's going to give me the same output almost all of the time. Not always, but in practice, pretty much all the time. And that means you have a repro command for detecting when you've made your code not flaky. Right? I don't know how many of you have tried to find that weird bug that shows up sometimes, but not all the time, and you just don't know whether or not you fixed it. You think you found it, but you're not sure. Show of hands, who's had that experience where you've got like the Heisen bug, you might have fixed it, but it might have just been, the tip of the iceberg. So this is nice. This helps that problem. Now, wardens don't catch everything. We're doing some experimentation right now to actually work on a less binary system of allowing flakiness. So when we do identify something as being flaky through this method, we just turn it off. I'm going to assert that it is better to turn off a test that is flaky than to leave it running and erode your trust. Trust is crucial. Right? You want people to listen to every single thing that you tell them. You want to be correct. And if you're not, people don't pay attention to anything. So we are working on solutions that are less binary than this, where we don't just have to categorically turn off things that are flaky that we detect in this way. And ask me about it later. All right, so much better world now. We've got labeling, we've got less flakiness because the wardens are involved. They've kind of said, hey, these tests aren't allowed to run anymore because they're crap. And that gets us to a pretty good world. But you'll notice here right now, I just have, is it good or is it bad? That's what I have right now. And that's great, right? This is miles ahead of where we were back in the day where I had 10% of red. But wouldn't it be nice if we had this? And this was yet another thing that we did that was, frankly, not all that hard, but that changed the way that we did things dramatically. We just said, here's the error message. If you mouse over any of those things that are bad, it's going to tell you exactly what went wrong. Sound simple? Well, story time again. Used to be, back in those same days, years ago as an intern, we didn't have this. If you wanted to know why something went wrong, you had to find the logs, which wasn't easy, the UI was awful, and hope that you could find the actual error message. Log files can be huge. Error messages are usually at the bottom. They're not always at the bottom. Sometimes they say error, sometimes they don't. Turned out this was a really hard problem for engineers. It didn't scale as we grew. Doesn't scale. Finding an error message, how simple is that? How important is that? So what people would actually do, because they didn't know how to even look at the logs, was they'd build it locally. And then they'd wait for however long the build takes. So sounds kind of stupid, but we just wrote a bunch of regexes. We said, here's the error messages that we've seen, right? This is the wisdom we have acquired. This is how to find them. We just grab those from the log file and we show them right there on the screen. And now with this bug, I don't even need to run the build command on my dev box. I just say, oh yeah, I wrote a typo. Let me go open my editor, fix that, save it, send it back out. Easy. All right. Well, I've talked to you now about a whole bunch of automation. I've talked to you about how our error messages, we made them better so that no matter what, you got better diagnostics. We talked about how we're running all those builds and tests for you. Everything, I didn't mention this, but everything that is transitively affected by the stuff that you've touched. So we're going to capture anything you might have broken. And we've talked about eliminating noise. We've talked about labeling so that people actually trust you and they can trust different categories differently. Once that's all done, where does the human come into that equation, right? Code review, most people, I think, assume is about humans. And for us, we actually try to minimize the human component, right? That's a goal. So the human's job is to look at the automation and say, yeah, that looks right? That's real issues in your code. Or, you know what? No, that's noise. That's a bug in the automation system itself, and they are the ultimate decider. They get to decide the machine is full of crap, let's ship the code. Which is a feature. It's a feature that you have an escape hatch to just say, go for it. But there is this middle thing. This, I call them meta-correctness checks. The reason why we still have humans do more than just say, yeah, that looks good, give it a stamp. And it goes back to our definition of broken, because all I've told you so far is that we run the builds and the tests, and I told you that's not enough. You do more than that, but still not enough. There's a human component here. So what might a human do? Let's think back to what we were talking about when we talked about brokenness. What might a human look for in a code review? Yeah. Oh, sorry, I saw a hand. Can you understand so is the code readable? Yeah, absolutely. If the code's not readable, if it doesn't conform to your style guide, absolutely, like, that's a job for a human. Great, what else? Perfect. Yeah, so does the code do what it's supposed to? In every case, not just what you tested. If it's a UI, does it look like we wanted? Is what the customer wanted? All that kind of stuff. Well, performance. Right? A human might say, oh, you did an O of n cubed topological sort. There's an O of n algorithm for that. Right? Go do that instead. So all of this stuff is stuff that a human might do. Now, here's the thing. Part of my job is to make it so that you don't have to. It's to take things from that meta-correctness category and move it to automation. So one of the things that speakers like to talk about at these events is Clang format. One of the first audience suggestion here was, is the code readable? And that could mean many different things. I don't want to pretend like Clang format solves all of them or even most of them, but it solves a category. This is a tool that you can run. It'll format your code according to the style guide of your company, whatever that style guide is. And you run it, and it fixes everything. So for us, we actually include that in the process. It happens before you submit the code. We just make sure the code is formatted. And so anything that you can take from being something that a human finds to something that the machine finds is a productivity multiplier, is scaling, is how you develop correct code at scale, is how you don't need every single person at your company to have the same knowledge, to have acquired battle wounds, basically. That's what we're talking about here. Okay, so we ship the code. There's a big green button. You push the code. Not quite. Right? I told you this was a story from start to finish of how we're shipping code. Before you get to finally send it out the door, we've got a pop-up. Right? Who loves pop-ups? There's a very important reason we have it. And it goes back to people who are new to our code base. Whenever we had someone who wasn't familiar with our code review tool, either they're new to the company or our code review tool is mostly the same for mobile development, but not entirely the same. There are subtle differences. People miss things sometimes. Or we've had people who've just had off days. They kind of forget that, oh, they ran the tests 5 days ago. Maybe they should run those with a more recent revision. And so we pop up this reminder, hey, something's broken. Do you want to stop? Do you want to take a minute and fix that? And it turns out our numbers show 50% of people do. Right? When we show this box, hey, here's some issues you might want to care about. People stop, people rethink, people say, yes, you're correct. And 50% isn't the greatest ratio. We've got work to do. And in a perfect UI, you might not need a reminder, but it's important. All right. I'm going to go off on a little bit of a tangent. This is kind of a sidestep from our story just a little bit, to talk about how we can get you information faster. So, show of hands. I've never asked this question. Who here is satisfied with their build tool? Anyone? I'm going to put my hand down. Awesome. Right, so however long the builds and tests take, it's not fast enough. That's the universal consensus in this room. And we wanted to do something about that. And so we invented this thing called Sanity Check, and all it does is it says, take the list of files that you touched, just those files, run them through Clang, don't even give me a .o file, just check the syntax. Run the most basic sanity check that you can. Is the code okay? Is there some, massive flaw in this that we need to know about now? And we can give you this answer blazing fast. Right? So you put up the diff for review, and we're going to tell you, hey, I can tell you never actually compiled that. Or we use actually multiple compilers, so it could tell you things if you hadn't built with Clang. So this is nice. This is speed. And it's proportional in complexity to your changes. It's not proportional to the size of the code base. It's not really all that proportional to the size of the dependencies. It's just what files did you touch. So it's a nice technique. All right, we've done this whole code review process. We've shipped the code. What gets through? There's some stuff, right? It's undefined behavior can happen. There's stuff that only appears under load. There's all the other things, the meta correctness checks that maybe a human misses. All that can get through. And so I want to talk to you about that first category, that undefined behavior category. Who in the room has used address sanitizer? How about heard of it? I'm hoping that when you all go home, you're going to take whatever you work on, go with, I'm hoping you compile with GCC or Clang because it's all that it works for, but compile it again, add a dash, I think it's fsanitize equal address, and just run your binary, run your tests, run whatever. It's going to tell you real actionable bugs, right? Crazy complicated bugs. This example's simple. I'll show you the error messages for this, but it works with hundreds of threads, probably thousands. It works with way more complicated stuff, and it's going to help you find things that you would have to have be done by a human historically, right? So it's a tool that's going to catch a whole ton of memory-related issues. So here's one I've got for you here. We allocate some memory, we delete the memory, then we use the memory. Obviously broken. And if you run this binary, you just compile it with address sanitizer, you don't need to do anything else, it's going to tell you what's wrong. And what's more, it's not like GDB where a human needs to be involved to get the information. It's just going to print it for free, right? You compiled with it, therefore it will tell you all the bugs. It's a lot like Valgrind in that regard. Different trade-off than Valgrind. For speed, it runs way faster than Valgrind. It does cost you a separate compile, but it catches a similar-ish class of bugs. Now, it's trying to tell us in English, right? It's not quite English, it's not quite human readable, but it's really trying. And this is a pretty good diagnostic. It tells me address sanitizer, error, heap use after free. It tells me that there was a write that happened that was invalid. It was a size 4, so probably an integer. It tells me the line number, the file, hey, in your main function, that's where it happened. And then it tells me you freed that memory, you called delete on the previous line. So right there, that's my bug. Right? It's just right in front of me. The tool told me exactly what went wrong, which is awesome. Okay, well, I've kind of lied. And I lied in saying that this is the output. The actual output looks like this. Right? So it's a little bit bigger. There's all kinds of stuff in here that you don't need, pretty much ever. Sometimes, yes, but more or less never. You don't need the hex addresses. You don't care about the sysdep stuff, the main thing. Shows up in every single trace. You just don't care. There's a lot of information here that's just noise. So I mentioned we like to extract better error messages from stuff, and we did that here. We ran another series of regexes and a bit more stuff. We made it so that the file names and the function names are aligned with white space that makes it easy to read. And it turns out this is huge. Kind of silly huge for getting people to pay attention to these bugs. Because I asked you, who's familiar with ASAN in the crowd, and not that many hands. And frankly, not everyone at Facebook is familiar with address sanitizer. So when they see one of these stack traces, because we run them for them, it might be the first time they've actually seen one, even if they have heard of the tool. And if the output that they get is this, that's intimidating. Right? There's an activation cost for an engineer to go and actually fix something. You can have a bug report that is correct. In my experience, these bug reports that Address Sanitizer gives you are reliable. And even with that information, it's intimidating. So I cut out some lines. I rearranged some white space. What's the effect? The effect is that people cared. The effect is that people listened to what we told them, that they fixed the bugs. That even for the experts, it's easier to understand, easier to read, easier to root cause. These are all good properties. All right, well, if I haven't convinced you at this point that error messages matter, There's so much cool stuff you can do when you actually start digging them out. Just throw out one more idea. If you had a way of getting all of the error messages in your code base reliably, like extracting them from the logs, maybe doing a pass on them to kind of remove information that changes every single time, like the timestamp. Suppose you logged that. Suppose you logged every single error message at your company. What if you had a database of that? What if you could say, what are the top 10 error messages at my company? That's an impact multiplier. That's an opportunity. So if you're not already extracting error messages, if you're not already logging them, take a look. Okay, I've talked to you about activation energy. How do I get a developer to fix a bug that I know about that's already shipped, that's already out there? Before a bug goes out, it's easy. You know exactly who to talk to, and they can't ship the code because there's a code review involved. They're not going to be able to send that code out. But once it's there, what do? And, okay, no, we're on the right slide. You need to have a lot of information. Developers, I don't know about you, I like to focus on the new stuff. I don't like to go back and fix the old stuff. I know I should, I do, but that's a context swap. Context swaps, well, there's an image on Reddit that actually captures this quite nicely. It says, someone said, quick meeting, 30 minutes. And so the programmer goes, they put that meeting in their calendar, and they put one before it that says, preparing for the meeting, got a context swap, and they put another one after it that says, all right, now like building back up to doing real work. And so really for your quick 30-minute meeting, you've eaten an hour and a half. And so how do you convince someone to actually do it? You need the repo, you need the error message, you need to tell them exactly, like, is it Clang, GCC, ASAN, whatever, what's the history? Is this flaky or not? If it is flaky, try and not even tell them about it at all. And like, how important is this? What's the magnitude? Did I break one thing, or did I break a core piece of library that affects literally everyone? Big difference. And again, I want to tell you a short story, which was, years ago, the way we did this was awful. When you broke something, let's say a core piece of a core library somewhere, that affects, I don't know, let's assume a small number. Let's say 1,000 tests, right, for a core piece of library. That's a small number. What if I sent you an email for every single test that you broke? Would you like that? Would that be good? Sure. So, you might want an email, right? One email, good. 1,000 emails, not so good. And obviously we were doing the wrong thing here. Obviously we were sending the 1,000. So we learned the hard way. Developers just shut down and don't even look at any of their emails when you send them 1,000 emails. Don't do it. I've got some strategies for you that you can take home. Simple stuff, really. If you have GCC, Clang, ASAN, whatever, it fails in multiple of them, just assume it's the same bug. If you've got a single CPP file with 100 tests in it, and more than one of those has failed, just call it the same bug. Doesn't matter if it really is, because you're going to tell the same person anyway. And the final one that's kind of cool is something we call fail rev. If you figure out that the revision where something first started appearing broken, well, then it's the same issue. It's the same person responsible, at least. So you could do this with a bisect. You could do it by just continuously running your tests. You would then know. There's lots of ways you can calculate that information. But if you know that things started failing at the same revision, well, then it's the same bug. Okay. There was this question that I deferred at the beginning of the talk. And that was, who knows about a particular project? And in a small code base and a moderate code base, fine, easy. You might even recognize the coding style of whoever wrote that file. But when you're talking thousands of developers, this is a hard problem. And the reason I want to call that out is if you don't know who to tell your battery of information, hey, this is broken, here's all the proof, here's, it's reliable, I've gotten rid of all of the noise, I've given you all of the debug info, the repro command, the error message, whatever. If you don't know who to tell, doesn't matter. Just doesn't matter. And so nowadays we're in a good state. We have this information encoded as metadata around the code base. But as you might imagine, I like to tell my stories of how it used to be. It was not always that case. And we pretty much just had the source control, blame, and logging facilities for this. So this is a really important question for fixing stuff, for not shipping broken code. Okay, I'm going to wrap up in a minute. I want to give some credits. I did not do all of this. It's a lot of work by a lot of different people, and I just have to put their names up there because this is really awesome stuff. All right, so we started with these. We're going to end with these. How do we prevent code from breaking? I've walked you through a story of making a change to our code base. I've walked you through this story of, hey, let's make sure we have good error messages so people can catch things before they put code up. Let's have a code review process that accumulates all of the wisdom that all of those thousands of engineers have learned over time. Right? How do you do that successfully? How do you get rid of the noise when 1 in 1,000 failure chance is too much? Right? We've talked about all this kinds of stuff. And even if you get all of that right, we've seen how it can crumble with one missing answer. Who do you talk to? Right? There's all of these layers to this problem. And trust is a huge component as well. Now, I've told you what broken could mean in your code base. And it's not simple. It's why code reviews are complicated. It's why it's taking us a long time to get tooling to automate more and more of this stuff. The ecosystem has never been better in C++. But we still have a long way to go. And we've talked about error messages and why it's not just good enough to say, yes, it failed. We need to tell you why immediately, right there on that screen, because build times are awful. There's all these subtle interconnected components. And I hope that I've given you an appreciation for why this problem is hard. Thanks.
Okay, questions time. Anyone has a question?
Yeah.
So I wanted to ask you about how fine-grained your testing is with respect to the number of commits, because we have observed that sometimes the sheer amount of commits that come from large group of developers is too much to run the tests on every of them. And
yeah.
Do you have any experience with that?
Absolutely. So awesome question. This is something that we are actively working on. So let me tell you kind of some of that story, and then I'll elaborate into what we're looking at for the future. So the easiest thing you can do to build and run your tests for your project, if you're a small project, probably the thing you want to do when you're small is build everything, run all the tests. Right? That's just easier when you have a small project. When you get to be a little bit bigger, and this is what we've historically done and what, for the most part, we're still doing, you don't want to run everything because you can't. It's too expensive. You don't have enough machines to do it, even if you distribute the work. It's just too costly. And so at that point, the next easiest thing to do is to say, okay, I'm going to use the build graph, kind of the dependencies in the system that are specified in. For us, it's a buck file, but for you, it might be in your make file or whatever else. Only build the things that are transitively affected. Right? So you're still now excluding a huge part of the build graph. You're not building everything. You're not testing everything, but you're still testing a lot. So that's kind of where we're at today. We're experimenting with some new stuff. And we're working on ways to reduce the amount of things we need to build and test by more than 50%, still catching all of the bugs. Now, the more complicated way we're doing this involves some machine learning. We've got a model that's reliable and not, it is deterministic, which is good. But the part of that model, I think the most important part that we're still experimenting with is one simple idea. And that is, instead of building all transitive dependencies all the way down, it turns out that if you just say, if I only follow 3 or 4 of those dependencies out, let's say, right, pick your number, might depend on your code base. If I only go a certain distance, let's say I draw a circle around the files that I touched and follow that out to a distance n. That's a much smaller subset of the code base. And what's more, basically every single bug is in that subset. Right? Once you account for noise, once you actually remove all the things that are flaky, you'll actually find that most of your noise lives outside that circle because it's far away, right? You probably didn't affect that. If it fails really far away, it's not your fault. So that's basically my answer is you can start by building everything, you can then switch to transitive stuff, and we're kind of working on a more nuanced story to that is looking very, very promising.
Okay, thank you. I have maybe a second question on the fun part. Do you have to have a Facebook account to apply and work at Facebook, or are there people without Facebook accounts?
Sure. To apply, you do not need one. Once you get there, I know you need. So we have a kind of a product. It's called Workplace, and so what it is it's a fork of your Facebook account that is just for business, right? Because groups, it turns out, are an amazing way to communicate. I don't get, reply all email threads. And that just doesn't exist for me. It's not in my world. I get a Facebook group, I can pick my notification preferences, and that is required. You need to have that just to be able to function at the company. So I don't know if you need a personal one. You definitely need a workplace one. Yeah.
Yes, what happens to this maybe flaking tests, which are disabled, and then what?
Sure. So once I disable a test because the warden found out it's flaky, what do I do then? Well, I mentioned we do send notifications. We send out an email to whoever's responsible for that test. We say, hey, this is broken. There's also dashboards that tell you, I've got a project X. What is the health of that project? Which tests are not in an optimal state right now? You can go back and fix that during like a tech debt week or something like that. But we also can automatically detect things that were disabled by the wardens, whether or not they've been fixed. Right? So assume I turned it off because it was flaky, because I found it with a stress run. I could run another stress run and say, oh, it's good now, and turn it back on. Now, that's not quite the answer because flakiness is flakiness, and you can't trust those results. But it's not that hard to imagine a system that correctly identifies when something's been fixed automatically. And you can also even detect the diffs that fix that code. Right? Automatically, you can do stuff like that. So ideally, you turn those things back on with automation. In a world where you don't disable things, you might actually just measure the amount of flakiness and hide the things that are flaky, and continue to run things, just hide the results that are flaky. And if you do that, then it's much easier to just gradually say, oh, this test has gotten better, so stop hiding the results that are awful. It's a nuanced system. It's an area that we're always working on. But yeah, you obviously don't want to leave tests to bit rot forever.
Any more questions?
So how often if it happens that you're disabling the test that it was supposed to be flaky, but the code was actually flaky?
I see. So is the question, how often do I disable a test for being flaky when it's actually the code that it is testing, the production code that is flaky? Was that the question? Then the test is, I see. So the fear is that we're hiding real flakiness. That would be the fear. So let me start with kind of one answer, and then I'll give another one. So my hope is that many cases of flakiness like that can be detected with tools like Address Sanitizer, or there's a thread sanitizer that catches race conditions. There's a whole bunch of tools that can deterministically tell me that something is failing. And what's more, even if Address Sanitizer sometimes tells you about a bug and other times doesn't, it turns out Address Sanitizer knows what it's talking about and is really, really reliable. So what looks like a flaky issue on an Address Sanitizer test may not actually be a flaky issue at all. And we kind of have different rules for that. Now, the other half of that is, did we actually hide something real? And again, there is a notification that goes through that says we turned this thing off because it started looking noisy. So it's not like we didn't tell you anything. It's not like we swept it under the rug. But what we can't have is your flaky product making flaky tests, which then get in the way of other developers doing work because we claim that they broke it when in fact it's not their fault. So it's still important to turn it off, but there's that notification and the dashboard that lets you keep track of that stuff. So it's still a hint to the developer in the same way. All right, it got dark in here. I wanted to try something fun. Is that okay with everyone? Is it all right if we try something fun that never done this before? Has nothing to do with the talk. All right? I don't actually know what the weather is like in Wrocław. Do you get thunderstorms? We're going to make one in this room. That's what we're going to do next, okay? So, few basic actions we're going to do, right? So one of them is we're going to rub our hands together. Some of us are going to snap our fingers lightly. We're going to tap on our knees. We're going to stomp a bit. Maybe we'll make the theater below us a little noisy. That'll be fine. So let's give this a whirl. Can we all? All right, I want the people on the sides to start doing a little bit of snapping. Yeah, you can hear kind of the rain, it's starting up. Let's, just the people right here. All right, and back to this. Got a little quiet, all right? All right. All right, who likes to be loud? Let's get some stomping. All right. Storms aren't always loud. And then it's gone. Thanks.